In this problem, we want to transform this given function y equals 3 over x. So that's not the parent function for the family of reciprocal functions, but it's a slight variation of that parent function. It's already been stretched vertically by a factor of 3. But we want to take that function, that's the starting point that they're giving us, and we want to transform it so that it will have asymptote lines of x equals 5 and y equals negative 7. So normally we know that the asymptote lines for the parent function, or for this function, y equals 3 over x, would be x equals 0 and y equals 0. The x and y axes would be the asymptote lines. So we need to transform this function so that it has these asymptote lines. And when I look at this first one here, an asymptote line of x equals 5, if it's gone from 0 over to 5, it's moved 5 units to the right. So how do I transform this function 5 units to the right? I subtract 5 in the denominator with the x. So I would have y equals 3 over x minus 5. That would move it 5 units to the right. That would make it undefined where x is 5. Now, we need to move it down to make this horizontal asymptote go from y equals 0 to become y equals negative 7. So just to move this thing down 7 units, I just need to subtract 7. And I've created a new function that took the original given function, y equals 3 over x, and transformed it so that it will have these given asymptote lines. So what if we change this problem slightly? This problem back here that we just looked at, where we had the function y equals 3 over x, and we had to write a new function that would have asymptotes of x equals 5 and y equals negative 7. When we did that in the first part of this example. Now, what if I add a stipulation to it where I want it to pass through a certain point? What if that point is 6, negative 1 in this case? If I go ahead and graph the function that I had previously created, you'll see that it does not pass through the point 6, negative 1. So I need to do something to it to make it pass through that point, and that is going to be dealing with a stretch or compression or reflection to make that happen. So let's go ahead and go to the graph, look at the graph of the previous function we have, and see what we still need to do to it to make it pass through the point 6, negative 1. So here you can see the graph that we had created before, where we moved the function right 5 units and down 7 units to make it have those asymptote lines of x equals 5 and y equals negative 7, like the example had asked us to do. As you can see, it does not pass through the point 6, negative 1 like we're now asking to happen. I'm going to go ahead and plot the point 6, negative 1 so we can see where that point is. So there's that point, and this graph is not passing through it at this point in time. I can look right here, and I see that it is passing through this point right here of 6, negative 4. I'm going to go ahead and mark that point on the graph there because that's pretty important to notice. Right there. So you look at that point right there on the graph in comparison to the intersection of the asymptote lines, you can see that I've gone over 1 and up 1, 2, 3 to get to that point. And you can see that 3 there being 3 times what you would see for the parent function. Normally you would go over 1 and up 1, and that point would be right there on the parent function. Right here. But since I've already started off with something different than just the parent function for this family of reciprocal graphs, I started with y equals 3 over x, which already was showing that vertical stretch by a factor of 3 to get to here. Now I need to change that to get it up here to 6 with that. So to get it from a vertical change of 3 here, so that this point is now actually up here at this vertical change of 6, I need to double that vertical change. So instead of having this 3 over here in my numerator, I need to multiply that by 2 to double that to make it a 6, like that. And now you can see it does in fact pass through the point that I needed it to pass through. So that's how you can kind of maybe see how you need to apply a vertical stretch or compression to it to move that point to get it to pass through a certain point. So when I told you I needed to pass through 6, negative 1, I was actually telling you that you need to stretch this function that I had given you, y equals 3 over x, vertically by a factor of 2 to make it y equals 6 over x, and then perform these other transformations to it as well. So that's kind of how that would work. So let's take a look at this problem now. Notice I've taken the 3 out of the numerator. I've gone back to just the parent function, y equals 1 over x, instead of y equals 3 over x for this last example. I didn't want to make it overly complicated with that. So I now have to transform the function y equals 1 over x so that it will have the asymptote lines of x equals 5 and y equals negative 7, the same asymptote lines we've been talking about before, so we already know how to transform it to do that. But now it needs to pass through the point 4, negative 5. So let's take a look at how this transpires, maybe look at the necessity of a stretch or compression or maybe even a reflection to make this happen. Okay, so here we are. We have our function y equals 1 over x graphed, our parent function for our reciprocal family. We need to transform it in such a way so that it will have a vertical asymptote of x equals 5. That means we need to move it 5 units to the right. To move it 5 units to the right, we need a minus 5 in our denominator, and we need to have the horizontal asymptote of -7, so we need to transform it 7 units down, so we need a minus 7 here at the end. I'm going to go ahead and graph those asymptote lines of x equals 5 and y equals -7 again. And let me set the color of those to red and dashed like I had them in previous examples. So there we have our asymptote lines. So here you see the graph of that function after those transformations to get the asymptotes where they need to be. And you can clearly see that it's not passing through the point 4, -5. As a matter of fact, it doesn't have any chance to pass through the point 4, -5 without a reflection. Think of these asymptotes kind of breaking this up into quadrants. I know these aren't the actual quadrants because they're broken up by the x and y axis, but this graph is in quadrants 1 and 3, and we've somehow got to get it into what would have been quadrant 2 if I'm using these asymptote lines to break it into quadrants. So to be able to do that, I need to reflect it over this asymptote line or reflect it over the y-axis before I start doing these transformations. So to make this thing reflect over the I said y-axis. I couldn't reflect over the y-axis. I meant x-axis. I'm going to reflect it over the x-axis by just putting a negative out in front like that. And you can see now that it's at least in the right region that it needs to be, but it still doesn't pass through that point. So now I'm looking from the intersection of the asymptotes. When I move over 1, this is going up 1 unit right now, being represented by the 1 on top. I need it to go up 2 units to pass through that point. So I need to double that vertical change. So I need to multiply my numerator by 2. So instead of -1, it needs to become -2. Now that I've done that, you can see my function y equals -2 divided by this quantity x minus 5, then decreased by 7. It does have the asymptote lines that it needs to, as outlined in the problem, and it does pass through the point that it needs to pass through. So by recognizing that that point was kind of in a region that was going to be impossible to make the graph pass through with while maintaining the given asymptote lines without a reflection, we had to perform a reflection to make that happen. So once we reflected that over the x-axis, and then we moved it the right 5 and down 7, we still needed that vertical stretch of 2 to be able to make that happen. So altogether, this function moved right 5 units, reflected over the x-axis, stretched vertically by a factor of 2, and finally decreased by 7 units, moved down 7 units, will pass through the given point and have the given asymptote lines. I hope that makes sense. If not, reach out to me and I'll do the best I can to explain that. I'm doing the best I can with a video from my basement, so that's what it is.